Hey guys, welcome to the Guild. Excited to have you here.
That's great. Happy to be here, Joe. Vanshu and I are extremely excited to talk about AI agents and see what the audience thinks about it, and especially in the realm of test automation. And eager to get started.
Absolutely. The floor is all yours. I'm really excited to see it myself because, like I said, it's a topic I think isn't covered enough. So thank you so much for doing this training. We really appreciate it. So the floor is all yours.
Sounds great. So let me share my screen. Great. So hello, everyone, again. So my name is Anand Rao. I represent Datagaps. I head product marketing here. And today we are going to be diving into Agentic AI and how it's revolutionizing ETL and BI testing, helping organizations such as yours achieve faster, more accurate, and automated QA of data. So just some background. So traditional testing methods have kind of struggled with the scalability, the complexity, and the changing data landscape. And Agentic AI now promises to transform this process by enabling real-time anomaly detection, intelligent test automation, and continuous monitoring to ensure you have the trustworthy, high-quality data for analytics and decision-making. So we'll talk about AI-powered automation and how it's reshaping this whole DataOps realm to charge your data validation efforts. So here's the agenda. So data quality and integrity, as I said, essential for AI-driven data ops, basically. Any flawed or incomplete data results in inaccurate insights. And so first we'll look at how AI-powered testing tools outperform traditional methods by enabling all this real-time monitoring for anomalies. Data governance and compliance remain major challenges because of all the regulations in place. And we will be talking about how you can enforce the data accuracy by looking at the lineage and ensuring that all the regulatory policies are followed. And then we will switch to BI validation, how this becomes better with all the AI enablement, how all the reports are consistent, how the schema changes are tracked, and how accurate the data is. And then we will have a live demo showcasing all our automated validation efforts and governance capabilities that we have in our product suite. And we'll conclude with Q&A and talk about how you can experience all these AI agents by yourself. So let me set some context here. So modern enterprises have faced the challenge of ensuring the data is accurate and trustworthy in this complex landscape. So when business processes terabytes of data every day, manual testing that is slow and error-prone is not able to scale with these complex ETL processes. So according to Gartner, the 2024 report, poor data quality costs organizations an average of around $13 million a year. So even a minor schema change can cascade into faulty reports, which lead to inaccurate business decisions. So to overcome this, AI-driven automation is transforming testing and validation. So technologies such as generative AI and agent AI proactively detect anomalies and automate this whole validation process, ensuring continuous data integrity. And they do this at scale. So by replacing the reactive fixes and with the proactive monitoring, AI reduces the risks before they impact the analytics. So AI-powered solutions ensure the data is trustworthy with the proactive anomaly detection, the schema validation, and any kind of data reconciliation. So these advancements have reduced the need for human intervention, but of course, a human needs to be present to oversee the AI. And this has enabled faster decision making and accelerate the analytics process. So whether you're a data engineer, a business analyst, or a QA professional, understanding AI-driven data ops will give you the tools to make sure that you make more reliable, more data-driven decisions. So let's take a closer look. So we talked about comparing AI testing with traditional approaches. And first is the speed. So as in kind of experience, traditional testing is slow and manual, and every test case has to be written, executed, and analyzed manually. AI automates this process, continuously validating the data with minimal human intervention, and therefore reducing the testing time. The next is coverage. So traditional tests is often limited to the predefined static test cases. So you might miss some data anomalies. So AI, on the other hand, uses machine learning to identify the patterns in the data and cover those edge cases that traditional approaches might overlook. This ensures that data validation and data integrity is improved. Finally, it's around maintenance. So traditional testing, frequent updates are required to maintain the test scripts as the data models and the schemas evolve. So AI testing, on the other hand, learns these changes and adapts and dynamically changes to the data pipeline changes, reducing the need for constant updates of the test scripts. So let's talk a little bit about how AI agents have followed a different architecture in data ops settings. So we have a couple of different types of agents. Agents that are capable of reflection. They continuously assess and refine their outputs. So in ETL pipelines, they can detect those transformation errors that come up and improve the data processing logic. Next are, the tools such as the SQL optimization tools and anomaly detection tools and BI dashboard validation. So AI agents integrate with these tools to enhance the efficiency of testing. The next, you have planning and reasoning agents, and these AI agents determine the optimal validation steps, the schema comparisons, and the additional data quality checks to ensure that your workflows are reliable and in real time. Finally are the multi-agent systems. So here you have agents specializing, say, in data transformation, data validation, and compliance monitoring. So multiple such agents work in parallel to automate the process. So by integrating AI agents, organizations can proactively manage their data quality, reduce the amount of manual efforts, and accelerate the processing time. Now, narrowing it down to specifically ETL and BI testing, we have a couple of different ways we can look at agents. First is sequential AI agents that automate the test case generation, the data transformation validation, as well as the schema validation. And they do this step by step. They ensure that the smooth data flow occurs through the ETL pipelines and detect any discrepancies before they impact the reporting and analytics. The next is hierarchical AI agents, and these take automation a bit further by managing multiple specialized sub-agents. So these sub-agents handle any kind of anomaly detection, the BI report validation, or any kind of root cause analysis. So these activities enable organizations to scale their automation by having this hierarchy, while still maintaining the accuracy of the data. And then you have asynchronous AI agents that operate in real time, continuously monitoring the data quality, detecting inconsistencies, and taking automated corrective actions without human intervention. So by working alongside all these agents, minimize the downtime and improve the response times if human intervention is needed. So a study found that organizations integrating AI agents within their ETL validation cycles make it 30 to 50% faster. And this reduced manual effort leads to higher data accuracy, lower costs, and faster decision making. So we look at three different areas. ETL testing and data migration is the first area. And as you know, many organizations face challenges with schema mismatches or data type conflicts when moving data across different environments. So these inconsistencies often lead to migration failures and require a lot of manual intervention to resolve any structural differences they see between the two data stores. Next challenge is the transformation logic. So there might be errors in aggregation while filtering the data, and these often go unnoticed, leading to misleading insights in the downstream analytics. So validating these transformation rules manually is tedious and cannot scale. Therefore, it increases the risk of faulty data processing. The third, of course, is scalability. We are dealing with large data sets here. And, when ETL pipelines are bottlenecked, many organizations struggle to balance the data checks with performance. And this slows down the end analytics and decision making. And then, of course, manual validation is error prone. Any human-driven process introduces mistakes that propagate through to analytics and affect the business intelligence. Finally, is the concept of adaptive testing. I briefly touched on it. When schemas evolve, say you have new tables, new attributes, these evolving schemas require continuous test updates. And without automated adaptability, organizations struggle to keep the testing aligned with the changing data structures. So AI-powered solutions enable, all these challenges to be addressed. The one key advantage is the scalable automation. So AI frameworks provide 100% validation coverage or close to that, ensuring that all critical transformations are tested and all the blind spots from manual testing are never missed. Another major innovation is adaptively handling the schema's evolution. So when schemas change, whether due to new columns, altered data types, or any modified relationships, AI automatically updates the test cases, eliminating the need for manual adjustment. And AI also intelligently enhances the ETL validation by detecting any transformation logic errors before they affect the reporting and analytics. Finally, is all this parallel processing that we can do. The data sets are large, and AI-driven automation runs multiple validation processes in parallel, therefore improving the speed without compromising the accuracy. The second area is this whole quality management and monitoring. So AI agents, before using AI agents, there are several challenges to be addressed here. And with data coming from different sources, maintaining standard quality metrics is difficult. There are variations in formats, structures, and completeness, making it hard to enforce uniform validation rules across the organization's data ecosystem. The second challenge would be detecting pipeline failures and leading to anomalies. So the whole data pipeline process, it processes massive volumes of data in real time, making anomaly detection critical. So there could be like unexpected trends, missing data sets, or any kind of schema drift that can disrupt operations if not identified quickly. So distinguishing between natural data variations and actual anomalies remains a challenge. And then whole concept of scaling these automated checks with minimal oversight is a challenge. So when excessive manual intervention gets to be complex, so automated tools must balance this efficiency with the accuracy, ensuring errors don't go unnoticed. So to overcome these challenges with AI, organizations can detect quality issues before they escalate. So this is especially true in regulated industries where data integrity is essential, such as in legal and avoiding all the legal and financial risks. So AI-driven monitoring accelerates the data quality issue resolution by 50 to 70%, reducing the downtime and improving the pipeline's reliability. Now, a key advancement in AI-powered monitoring is this concept of real-time data scoring. So AI continuously evaluates the data sets based on some predefined data quality metrics. So this ensures that any kind of compliance and governance standards are met. And these quality scores provide visibility into the health of the data. It tracks the data's lineage. It logs the quality metrics, and it alerts teams if there's a risk of a compliance audit or a regulatory audit. And then AI is overall automating this whole rule and policy enforcement. So traditionally, data governance processes are manual, slow, and error prone, but AI now introduces real-time validation and automated rule extraction. So when you have these systems integrate with governance tools like Collibra or others, organizations can enforce the policies dynamically across the data pipelines, eliminating for the need for these manual compliance checks. The third bucket and final bucket is the whole BI, the business intelligence and dashboard validation. So this is your report and dashboard validation. So traditional validation methods have been time consuming and often fail to detect subtle data mismatches, any kind of broken visualizations in the reports, and any kind of security vulnerabilities. So first, challenge is around the regression testing for upgrades. So every time a dashboard is updated, whether due to BI platform upgrades or schema changes or data model modifications, there's a risk of breaking the existing reports. Identifying the differences in visualizations, filters, and KPIs is challenging without automated regression testing. And then there's the whole concept of maintaining the data integrity in the visualizations. So your dashboards may not look, correct, but they should reflect accurate data. So they might look, at an overall level, they might look correct. So issues such as missing values, aggregation errors, or data mismatches often lead decision makers to make incorrect decisions. And so this ensuring the consistency between the reports and the source data sets remains a challenge. And there's this whole concept of performance and security concerns. So BI dashboards must deliver insights quickly and securely. However, the slow loading times of these reports, broken filters, and any kind of unauthorized access can impact the usability as well as the compliance of these reports. So organizations struggle to conduct scalable performance and security testing to identify any potential issues before they affect users. So AI-driven automation enhances this report validation process, mapping to the right data and monitoring the performance. So AI automatically compares the key metrics, the filters, the visualizations across different versions of the BI software to ensure that there is consistency and detect any differences early. So this eliminates the need for manual cross-checking, reducing the errors, and accelerates this whole validation cycle. The second would be the data mapping and security checks. So most dashboards pull data from multiple sources, increasing the risk of any kind of mismatches or unauthorized access. And AI ensures accurate data mapping by cross-validating the reports against multiple data sets. It also enforces any kind of role-based security controls, preventing compliance violations and protecting sensitive information from unauthorized users. And finally, it's all about the performance monitoring and optimizations. So when you have slow dashboards which impact decision making, AI-driven load testing and performance monitoring identify those bottlenecks, optimize the report execution speeds, and ensure smooth functionality under varying user loads. So by integrating all this AI into the whole report validation and dashboard validation process, you're enhancing the accuracy, security, and performance of these reports while reducing the manual effort. So now let's switch to a live demo where we talk about these different capabilities. So Subhanshu, over to you.
Yeah, thanks a lot. Let me start sharing my screen first. I assume you guys can see my screen now.
Yes, looks great.
Let's get started. All right, thanks a lot for that. Let's get started. So before we jump into the actual showcase of how Agentic AI and LLMs in general are going to help us get to our point of automated validation, we kind of have to go through the basics once again. So we're going to spend about 5 minutes understanding the platform, why exactly this is the correct platform to use, and what exactly is the AI trying to achieve. Because that is a very important question. Because if, say, there's a question that's given to you as a QA engineer that, hey, validate these data sets, you have a lot of follow-ups. And those follow-ups dictate how you would like to run validations. And AI is not different on that particular front. So the first thing I want to discuss about the application is the engine itself. The application is primarily Spark-based and can be deployed and installed in your infrastructure or your client's infrastructure. The main reason for this is compliance, but the other main reason for the application being Spark-based is its scalability. Creating validations using a simple, kind of scrappy Python code is pretty straightforward, unless you have to deploy it for a billion record system with around 500 columns. That's where things get into scale. And so a Spark-based system, which can be horizontally scalable, is really helpful in these particular situations. More so if the same system is installed within your infrastructure itself, to the point that you don't really have to worry about compliance at any point. But going back to our use cases here, the first thing is to define that your engine can work with the data sources that you've defined. What you see on your screen are the connections that the application inherently supports. While these have a good chunk of your typical JDBC connections, flat files, nested objects, or hierarchical files like JSON and XML, as well as BI tools, there's an additional set of CData connectors, generic connectors, as well as API connectors. Main story here is that one way or the other, we need to define our connection to our data sources, a live connection for that, so that the test cases can be generated in a live manner and can be executed without any user intervention. Hence the need for live connections there. Another key aspect about the product is that for the application, all sources are treated in an agnostic manner. This is very important for a product-based solution in this particular space. just because a data set comes from Snowflake versus a data set coming from a CSV file, it should not affect largely the quality issues and other aspects that it might face. You should be able to apply the same amount of rule sets or validations on both the types of data sources. And our application thrives on that principles. So for the application, all of the sources are treated in an agnostic. Now that we've had that prelude on the connectivity to our systems, let's actually jump into a bit of theory class as to what data quality really is. And again, this will be just 5 minutes, but it kind of covers the basics of what we want to achieve. And for this, I'm just going to open up an existing use case to kind of set the stage. So let's say you have an incoming data set. This data set here is a transactional data set that I've picked up. Here's a preview of it. And I'm asking you to validate this particular set of records. The first question back you can ask me back is, well, on what basis do you want me to validate this particular data set? And therein lies the main schism within the philosophies of quality management. If I add a component, you'll see that the application comes with a suite of nodes, and all of these nodes can be used interchangeably. Like you can add as many nodes as you would like. You can define the test case template in any defined way that you're working with. But the basic gist is that you're going to work with one or more type of data sources, depending on the validations that you're looking for. You want to combine multiple files before validation? Do you want to run validations against multiple files? So on and so forth. So you can pick up any of the data sources that you work with. Processors are important in case you want to, say, massage or prepare the data before or after validation, or on that later. But in short, you can use SQL, Python, Scala, and other tool sets to achieve that. And then comes the main question about the schism. How would you like to validate your data? Do you want to validate your data based on bound rules? Examples here would be, you want to make sure that the data set does not have duplicates over certain composite keys. Do you want to make sure that the data set adheres to your business logic in terms of precision, in terms of aggregates being up below or above a certain range? Maybe ensuring that if you're working with license plates, those license plates are valid license plates. The list of these problem statements go on. And from our experience, different industries are going to have different niches there. But it all boils down to the specifics that you're either going to validate data on bounds or you're going to validate data based on source of truth. By the way, bounds just don't refer to, say, rules. Say you're getting a data set on a daily basis. This data set is about 1 million records strong. And if, say, by a chance today, based on the previous records today, you have received a data set and it's around 3 billion. So again, that's a 3 times increase in volume. There's obviously some change that your vendor has not given to you, and that is a red flag. I mean, if you want to apply the same examples, just apply it to your outgoing files. Say you as a data engineer, you process a particular file and you send it ahead to analytics. And that takes about, say, 10K records in total. If that thing increases 3 times, obviously some of your joins have gone wrong, or there has been some changes in the data which you have not been privy to. Validations on those fronts is called data quality within the application. So either it can be machine learning based, it can be AI based, it can be rules based. But the main gist here is that you're validating data based on bounding logic. The other side of the coin is reconciliation. So here, if you go back to our problem statement, if I give you a particular data set and I ask you, hey, validate this particular data, you can ask me, from where did this particular data set come from? If I tell you that, hey, we got a CSV file and we imported it into our Redshift table, please make sure that the import was correct. That's where you need source to target comparison. Basically, you need to define what your source of truth is. And the source of truth could be something that could be modified. More on that shortly. And then this source of truth is compared against the expected results. Whether be it in terms of raw record count, profile counts, counting the number of records, the aggregation, min-max values, metadata, or even multiple of these across an entire, say, medallion architecture to make sure as the data propagates through your system, you're capturing them. These 2 are the main pillars of data quality as a whole. And once the validation is done, that's where the post-processing comes in. I mean, just because you have found mismatches or you have found incorrect records, it does not mean that your job is done. You need to now fix the records, or you might want to go ahead with only the good records, and so on and so forth. And this does not even cover DataOps processes. Things like raising notifications, raising tickets, giving the reports out to your end users, and sending out emails in case there are anomalies found in the data. All of this process is something a lot of people do manually at this point. And what our engine aims to do is to automate this process quite considerably as well. So that in a nutshell is what the entire application deals with. And that in a nutshell is the anatomy of a particular test case. We're going to connect to multiple sources. We're going to run processing validation on them. And once the validation is done, we can either do a post DataOps process or a notification or ticketing service process. And of course, you can combine them as well. To quickly kind of get us started on the different types, I'm firstly going to discuss how the application works with data quality and ETL validation, and then discuss how AI comes into the mix, because AI is going to be doing all of this, what we're going to suggest. So once again, I have transactional data, and I want to run some black box validation on top of it. It's very easy because the application comes with a good set of rule sets, templates that you can work, and you can define everything ranging from a duplicity check to a null check, to quantity validation checks, to reference order pattern checks, making sure your license plates are in the correct pattern, and a lot more. This entire set of template is zero code and low code. So it helps you as an end user to define your rule sets. And once you've defined your rule sets, you can easily reuse them using importing, exporting systems, as well as easily reuse them across environments as well. That's one of the key aspects. You define it once and you reuse it as many times as you'd like. One of the coolest aspects about the product is that the list of operators right here that you see, this is completely customizable. So you can add your very own niche operators, as a lot of our clients from the federal agency, a pharmaceutical agency, claims agency, and a lot of other industries have also done inherently. And what does the application do with all of these, rule sets? Well, it performs 100% data validation. And as suggested earlier, it's going to segregate your good and bad records into different data sets. This is a key pointer here. We want to make sure that as an end user, you get to see exactly why certain records have been defined as incorrect. And if you look right here, it's telling me that these are the rules this particular record has failed. And if I look at the actual records, yes, 550 is greater than 100. And of course, the reference order ID was looking for a 5-digit number, not a 4-digit number. It should have been 02257. So that's how the application is kind of telling us exactly what are the good records, what are the bad records. And additionally, it's also generating a proper data quality score for you, which tells you exactly how this particular score works. This is basically the ratio of good records upon total records. Basically, it tells you what's the health of your particular records for this particular rule, for this particular table, all the way to a particular system itself in data quality. Now, one key aspect here is, as an end user, you can of course dig deeper and find out these data quality scores across multiple dimensions and multiple models. And the bulk creation of these rule sets and the understanding of which rule sets have to be deployed is something that the application is going to achieve using AI. Right now, what I'm just going through windows into is just an illustration of the engine's capability here, that in case there are records which are recurring bad players, there are records which have been called out as bad records, but in the latest refresh, they are persistent. The application has inherent functionalities to snooze them, to work with them, and also to track if those bad records were resolved as well. That's one of the key metrics here. And all of this comes inbuilt within the product, ready to be deployed in any system specific. Quickly now, let's discuss the other side of the coin, which is a source to target comparison. And what's the main use case for that? Well, if we open up one of these use cases right here, you'll see that if you're migrating data from any point to the other. Now, in this example, I'm migrating my data sets from SQL Server into Snowflake. I can pick up the entire data as is. And you'll see here that I'm working with basically a select star query itself. Just applying a select star query because I want to get the raw data itself. There's no transformation validation yet. I want to just make sure the migration is working as intended. In this case, extraction and loading. So I pick up both the objects from my system, and the application can automatically perform data comparison between the two, where once again, it's going to segregate your good and bad records into different data sets. The setup for this also is terribly easy. Just decide what data sets you'd like to compare. The application takes care of data type mismatches, column name mismatches, say extra columns present in one system versus the other, and everything in between. And once again, it's going to segregate your good and bad records into data sets, even calling out the records which are present only in one system and not the other. So in this example, we see that there are records present in SQL Server which are absent in Snowflake, meaning that there is a bit of data latency difference between our systems. Not just that, once this is done, if I want to, with the click of a few buttons, like in this case, I'm going to use the file sync component here, I can just save the mismatches into a particular location. And what this basically allows me now, and this is the test case which I have discussed earlier, where I can run validations on one or multiple data sources together. I can run multiple types of validations as well. And once those multiple types of validations are done, I can automatically raise tickets and automatically save the mismatches as specific records as well. Now let's bring in AI into this and let's see how exactly we can expand this and use AI to deploy all of these use cases together. So a key pointer here is that what the application inherently comes with is a lineage system, as you see. Now, this can be plugged in using, say, Excel files themselves. Mapping Excel files is something that we work with, or any documentation that you have lying around. This could be Unity Catalog, Purview, or the aforementioned Excel files. However, since we're being realistic here, many of our clients have this exact problem statement where documentation ain't that great. So we got to make sure that we can work without documentation as well. And so what the application is capable of doing is connecting to, say, stored procedures in Snowflake or something along those lines, and picking up the information from the queries there to associate which columns come from which columns. And in this example, I'm focusing on is order, is food order, is drink order, and others to kind of show you that these corresponding data sets and columns come from different systems. Of course, you also see that we have a data quality score associated with every column. And this lineage helps us track to see exactly, where exactly these particular data sets come from. So now let's try to apply this a little. Let's try to create our test cases live for a second. I've created this already, but where exactly does AI come into the mix? Well, AI comes into the mix to run validations on this. So here I've just asked it like, hey, I want to see if a particular order has all foods or all drinks item. The main reason for this is that I have the exact same flag present in M customers, but I want to make sure that the staging tables that you see right here, stage, or let's just go a little up, staging orders, staging order items, stage products, does this correlate and make sure that this value is actually accurate? That's my main problem statement here. And you'll see that, yes, as an end user, I can just define what transformations I'm working with here. I can even give it some additional prompts to fix the code. Again, this is very much like Codium, whereas you can type in, the application understands what you're working with and creates the query in accordance. And this thing can be done in SQL, this thing can be done in Python, and a lot more. We have a lot of these tool sets present by default itself. Now here what I've done is, instead of going ahead with the select star query, I've actually made sure, let's make sure that this particular transformation is working as intended. So I pick up the same thing except from my Mart layer. That's why we have M orders right there. And when I run this comparison, I see, well, everything seems to be matching perfectly. This is almost a perfect match. There are a few records which are present in the Mart layer, which are not present in the staging layer, which basically tells us that there's a bit of data latency lag. Nothing too crazy, but a bit of data latency lag, resulting in 500 extra records present in our target versus our source. But now let's dig deeper into this. Let's see a problem where these actually don't turn out as intended. So now I'm going to switch over to M customers. Now M orders was one of the, say, child tables or basically related tables to M customers. But here we see that it's coming from multiple tables. And you will see there's a column called first ordered at right here. See, this first ordered at is the column which represents the latest, the earliest and the oldest dates. That's what the first ordered at and the last ordered at is working at. By the way, the percentages that you see, these are data quality scores associated with these columns to let the end user know how accurate or valid the particular records are for that particular column as well. And of course, you can track them back to see exactly where they come from and where they go. That's one of the coolest features of lineage. But to go back to my use case right here, you'll see that as part of our system, I have something called Mapping Manager. Now, the main reason Mapping Manager is important here is that the application wants to create the test cases for you. I mean, you have 500 tables at the end of the day, and they're interconnected in the lineages that we have seen earlier. You want to automate that. And so the application can directly connect to your sources, connect to your targets, pick up the logic as it is from the transformation requirements document. Now, this could be the catalog, this could be picked from stored procedures and other facets as well. Once again, one of the key benefits here is if you have a requirements document, that's the source of truth. If you look into code, we are interpreting code at the end of the day, and that could be biased inherently. And of course, the code could be riddled with more unknown issues as well. So it's always better to have the requirements document, and it's always better to have an end user confirm the requirements document before the LLM or AI proceeds with it. This is just using AI 101 at this point. And what you'll see the application is capable of doing is creating the test cases automatically. You'll see one of the key benefits here is that even if I had, say, 20 columns within my data set, the application is going to create 4 test cases summarizing different types of calculations. Here, aggregations are summarized, as you can see, with sum. We have created a couple of them for subtotal and lifetime tax and other such calculations. Those date calculations are segregated into a single system. You can see we're also performing joins here if we really have to. And then the classifications and counts are again segregated into separate test cases. Yes, if we really want to, we can combine everything into a single test case as well. The only caveat there is that it becomes a little too complex for the end user to work with. And we suggest our end users to kind of stay free from that, unless you like to work with, say, code that looks a little like this, where you have, say, joining keys, where you have partitioning functions, multiple joins together, and a lot more, everything jumbled into a single mess. So again, we recommend against that. And so what the application does is inherently work with it. Of course, there's a lot more caveats here. You can just add your very own prompts as well to kind of fix the test cases on the fly. You can customize them. You can parameterize them, and a lot more. And the application creates these test cases for you. That's what you see right here. Here, instead of writing that select star query or providing the Copilot with prompts, the application has gone ahead and automatically created the transformation logic for us. We pick this up from source, apply to the target, and the target table need not be customized because again, that's just what we are trying to validate. And here we see mismatches, and this mismatches basically represent exactly what has gone wrong with our particular transformation logic. Obviously, the developer has applied extra logic to maybe filter active records, filter active orders, or something along those lines. But the end result here is that the requirements that we were trying to fetch from our system, that we were trying to get the latest and earliest order dates for a particular customer, those are inaccurate, 90% inaccurate in this particular data set. And so what we have achieved is transformation validation, completely automated with some oversight from an end user, created by the end system. And that's one of the coolest things that we have kind of created using our bleeding edge technology. The other facet here, apart from that, is the fact that after we are done with our transformation checks, we can again go back to black box testing. Just because you did not have, say, duplicates coming into your data set does not mean after transformations you might not have duplicates and other systems. So these type of rule sets and a lot more are automatically generated by the application to ensure that the data sets are working with the expected results of what we had defined. This again is completely generated using AI and kind of speeds up the entire process of an end user, and just any kind of manual intervention is overview. And of course, providing the logic to the product, because even an AI cannot or should not kind of hallucinate and try to assume a lot of things. So that's one of the key benefits and key kind of caveats I would put there with regards to using AI is context is king in AI. So as much context you can provide, the better it is. It's not the end though. We have a couple more examples before we hand this back to other systems. Firstly, the application can be thoroughly used in BI validations as well. So if you're looking for use cases where you want to validate your BI reports thoroughly, again, the functionality is present within the application itself. We won't delve too much deeper into this, but the basic gist here is that if you have BI reports which look a little like this, or maybe complex versions of these reports, and you want to make sure that the numbers in those reports are valid, the application can connect to the databases or data sources inherently and apply those complex transformation functions. As a different example in Tableau, I can just open up a financial report that we had prepared earlier. And this financial report comes with a few more specific types of use cases. So here you see that we have a financial report and we have a lot of KPIs and graphs that we like to validate. The application can easily pick up all the information in them, convert them into data sets. That's what you see right here on your screen right now. And then run validations against the data source itself. This could be any data source. And as you can imagine, the transformation logic is something we can pick up from data models and other systems as well. That's one of the key benefits. That yes, your data model might be pretty complex, but because we have access to the data models, because we have access to the data sets, because we have access to the filter combinations and a lot more in BI, we can create these kind of validations and call out specific graphs which are just inaccurate. So here we see that the numbers in our BI report are not in conjunction with the numbers that we have in our golden records. So that's one way of BI validation. Another way of BI validation is in terms of making sure that your visual elements, your parameterized elements, and other facets are also valid. Kind of show this point further, you'll see that the application inherently comes with, say, differentiation between reports. You have a proper summary, an AI report summary, which tells you exactly what has gone wrong between different versions of your report. Last Monday, we had, say, same day as a filter for our ship mode context, but this week we don't have it. There have been alignment shifts. There have been data differences. There have been measure definitions which have been altered. The formula for, say, profit ratio has now been altered from count to sum to count to count. Basically, any kind of changes, be it in visual elements, in numbers, in filters, in performance, and everything else can be easily captured within the application inherently. And that's one of the key benefits of the DataOps Suite BI Validator. Apart from that, there are a couple of test cases that we have to end on. The first one is that the application is capable of automatically finding out anomalies within your data set as well. This is part of ingestion validation or originally, but I'm just going to use a Tableau report to illustrate this point further. So say you have problem statements like this, where you have data which looks a little like this. Again, this could be incoming data. This can be outgoing data as well. And you want to make sure that the yellow spikes right here are valid. Now, as you can imagine, different categories are going to work with different patterns. And so you need a smart system to understand what these categorizations are and what is the best algorithm to deploy on top of it. You'll see that the application comes with these capabilities built in. While you can define a simple validation based on the aggregates, things like volume, things like minimum, maximum, sum, deviation, and all that. And these are pretty helpful. I don't want to undersell that if you want to keep track of your charts and you want to make sure that if something is going amiss, like in this case, the aggregation of our sales has skyrocketed, especially when compared to our previous data sets, well, that is definitely a red flag. Something has gone wrong. No sales figure looks like this and cannot be called as an anomaly. So that's where the application does call out anomalies. But observability is on top of this. You can think of it as its stronger version, because it can define categorizations, define the measures, choose the exact prediction method you're working with as well, and then provide anomalies detection differentiated for different categories. Meaning, like in this case, we see that 855 or 739 has been defined as an anomaly because for regular air, the y-axis is pretty volatile. We are from minus 200 to 600. But our other category does not have this problem. Here we are between minus 100 and 200 because there's a different algorithm that has been, machine learning algorithm that has been applied to this. And here in this category, something as high as 229 can be deemed as an anomaly. And that's one of the key benefits of using the application. Last thing, but not least, the application also comes with synthetic data generation. I do want to give it a quick shout out because this is where AI is also being used. And the main problem statement here is that if you have just a bit of production level data and you want to reuse it across different systems, maybe for, say, reusability in terms of stress testing, or you just don't have access to realistic data and you want to make sure you have those real errors coming into your system as well, the application can easily pick up a bit of sample records from a system. And of course, this will be automatically PII masked, meaning that it's going to, say, cover up birth dates, names, and other such information inherently. So that's something that the application does. And it's also going to keep track of the correlations that it has with other tables, as well as the correlations within the table itself. In this example itself, you see this is a demographics table. You'll notice that the marital status flag is going to be dependent on the age. Obviously, when if you're below 18, you're not going to have the marital status as M. These kind of checks and these kind of understanding and correlations are built into our product and creating synthetic data. Of course, once you do create it, you have a lot more options on top of this. You can really go deep into defining exactly what type of synthetic data you're working with. But this is another facet to make sure that you can run validations on your fake data or your synthetic data as well. Once again, powered by AI. At this point, I would like to take a pause because, again, we have covered a lot of information. But in a nutshell, what we've discussed today is the theory of validation, why scalability is pretty important, white box and black box testing, the different variations in them, why segregation of good and bad records is very important, and most importantly, where does AI really fit into this? AI fits into this to make sure any kind of manual tasks that are being done currently can be automated. Understanding the logic, creating the logic, understanding the data sets, creating the validation rule sets on data sets, and understanding the patterns of a data and creating rule sets to automatically find out if a particular category is outside, say, a particular subsystem. All of this and more can be done using AI. And that's why we are trying to push Agentic AI and AI agents as part of our product in the name of automation. And of course, saving a lot of end users with manual hassle and repeated work.
Awesome.
With that, I'd like to
we do have a quick question.
Yes,
So just share on your screen
yes,
that someone wants to know. How do you construct your spec or reference data? Is it done on some reference system in a dedicated test environment?
That's very close. So we provide two types of use cases there. Either if you have, say, a preview of records. So if you have, say, production grade records, like in this case, as I was showcasing the sample records, this is about, say, 100 demographics data sets. This is the best usage for us because as an end user, you don't really have to go into the data set and easily define individually what a particular data set should be. So this is the fast method. However, say you do not have any sample records and you're looking to create synthetic data from scratch, well, the synthetic data generator helps you there as well. You just have to define what exact systems you're looking for specific columns. So instead of the application doing that for you, you'll have to kind of get into the gist of it and do it. And then even that can help you create these synthetic data sets.
Awesome. All right, we have a few more questions. I want to stop sharing your screen just so everyone could see your awesomeness. Yeah, perfect. All right, yeah, let's get to some questions really quick. We have a bunch in here. Can AI agents look at the ETL BI code and generate test cases based on that?
Yes, we can do that. And as I said, with an example of, say, Snowflake stored procedures or Databricks notebooks, the only concern there is that that's like looking at existing code and using that as your basis. Validation happens in isolation. You need a proper source of truth, which is vetted, and only then you should be creating validation codes on top of it. Again, we're trying to meet people halfway there by looking at the code and saying that these are the requirements. But it's very helpful for an end user to come in and kind of confirm that, yes, this is exactly what I want. Because, there's no saying that the inherent code that was written earlier was not wrong or did not have some biases or did not hide some internal issues or errors. So while we can do it, it's recommended not to, and recommended to go with requirements documents as well.
Perfect. How does Agentic AI ensure realistic and compliant synthetic test data?
Well, the compliance part is pretty straightforward. We identify which particular data sets are PII automatically. We kind of do that with auto detect entity. And if something is not really, getting on that front, we kind of can do it manually as well. So that's one aspect where the compliance aspect is taken care of. With regards to realism, it depends on the base data sets as well as the understanding. Like if you're working with the demographics data set and you want the system to have some errors, because at the end of the day, you want to capture these issues, right? You want to capture if something is going amiss. In that case, the application does understand that, okay, you're working with synthetic data. Maybe, say a particular married flag of F might be better here. Because again, this could be one of those issues which can come up. So yes, the Agentic AI system knows that you're looking for some sort of errors, and it's going to base those errors on the mapping documents or any other context that you have. Because again, demographics is an easy example. If you're working with, say, medical data, it's very important for you to provide the context. So the Agentic AI system knows what to avoid or what can be bad data there.
Yeah. And to add to that, there's a feedback loop where a human intervention can come into place to enhance this accuracy of identifying the data.
Perfect. Next question. How does Agentic AI help here to validate Tableau data against Databricks Snowflake queries data?
Well, yeah, that was one of the use cases that I have skimmed through in the system itself, where we can connect to Tableau inherently. We can fetch the information generated by Tableau, meaning the numbers you see in your graph. This is after the application of dynamic filters and parameters and security models as well. If you want more information, we can always have a separate demo on that. But the application is capable of fetching information from that and fetching the same information from your Snowflake counterparts to make sure that the numbers in your reports match the numbers in your golden records.
Perfect. Next question, still loading, is how does it know that a data value is not right? How does it consume the requirements? How many false positives does this solution generate currently?
That's a very good question. With regards to false positive, our rates are pretty low, to be honest. And the main reason for that is, again, in a testing environment, we are much more, you'll be able to be much more sanitized. But with regards to how the application knows if a data value is inaccurate is either based on bounding rules, either based on transformation logic, or the expected pattern. It's very similar to how, when you start looking at a particular data set or start working with some records, you get an idea of what a correct value is. So you're working in finance, you know what an expected loan amount is or any expected payout amount is because you've looked at those values and you've looked how these values correlate with other tables and in general, an upper and lower bound. The application applies the same three techniques, except it's going to have an agent apply them. With regards to false positives, it depends on the context. We have seen if you provide it very little context, it's going to assume more things, and assumptions usually lead to false positives.
Great. We have time just for a few more questions. Going to the bottom for some good ones here. 1 second while it loads up. So one has to use the actual data ingestion tool, and in addition, have to use Datagaps. Who would keep the Datagaps in sync with the actual system, Azure, data factories, etc.? QA teams?
Yes. So in this case, I would say that the QA team is the ones who are going to take care of it, but it wouldn't be a hassle for a lot of our clients. It has not been, mainly because the application comes with a true CI/CD integration. So say you're working with Azure Data Factory and you're working with versioning there as well. So say there's an upgrade in a particular version. We have changed a particular transformation. That information can be easily relayed to our Datagaps suite. And again, you can link the versioning as well. So the version control is present within Datagaps as well. So at this point, if there are changes in your transformation logic, the application can pick that up, update a test case, and then create a PR request, so a pull request to review if the changes down the pipeline, because again, your transformations are going to have cascading effects. So you can review all these issues and then come back and tell you that, okay, after the changes, this is what the updated results look like. This is what the differences between the BI reports, the test cases, and all those things look like. And that is where the application comes in. So it's going to be the QA personnel doing this, but it's going to be highly automated. And I do want to repeat Anand's point here that a bit of overview from human is very much required here. At the end of the day, we can't completely automate everything out there with LLMs because of the slight chance of hallucination. AI agents have minimized it quite considerably, especially when compared to typical LLMs. But again, it's still an AI agent. We do want to add that grain of salt.
Great advice. All right, time for one last question. Ability to find, access, use third-party reference data. Example, federal NPI of healthcare providers, public DB published by government.
So I think this question is not that directly related with our system. But yes, if you're looking for reference data sets, the application does come with that in the Synthetic data section. So there's an entire section called fake data where you can choose what your providers are. And if you're working with, say, custom systems, so in this case, you are aware where this particular data set comes from, you can just pick up the mask data itself and let the application create the Synthetic data for you. So I would suggest the latter, but if you really want to go ahead and look for the application, we do have a good amount of domain sets within our fake data sets as well.
Excellent. All right, we have one last question. I don't know if you have time. Let me just show it really quick. And if you don't have time, if it's too detailed, we can take it offline. This has been sounds like a pretty good question.
Yeah. All right, let's read it out. So we know that while validating Tableau data against Databricks, writing DB query to fetch data similar to Tableau data is always a tedious task. How can Agentic AI help here? Can you show me some use cases? Well, it would be very similar to the exact test case which I have showcased, except instead of connecting to a data source like a JDBC connection, we'll define the exact same connection type to Tableau itself. So I'm not sure if I should share my screen, but we have a very similar use case there, where the actual transformation of the data, the query that we apply, that itself can be automated within the system. So that if you're working with, say, multiple tables, right? So if 6 tables combining into a particular report, and there's a transformation logic that uses all 6 tables, the application can create the query for you, given the context is provided. Now, this could be within Tableau itself, this could be in other systems, but yes, the application can create that query if the correct context is provided. We can have a proper demo on that later if needed.
Awesome.
Proper personal demo.
Yeah. So thanks again, guys, for joining us. Really great stuff. Some other questions in here, but I'm sure, like I said, people will be receiving a recording as well as emails to contact you if they wind up. You actually have a free trial, I think, and some demos as well. So,
yeah. So maybe I share a quick slide on that.
Yeah, let's do that.
So thank you, everyone, for sticking so long. Hope you enjoyed this presentation. So we encourage you to explore AI-driven testing solutions firsthand. So you can access our hands-on demo or trial of Datagaps AI-powered tools and apply these capabilities directly to your own environment. So scan this QR code here to request a free demo or see the AI in action. And we have shared a few white papers and case studies to help you understand further. So thank you for joining us today. And feel free to reach out to us at contact@datagaps.com. And we look forward to helping you accelerate your AI-powered data testing journey. Thank you.
And once again, thanks so much. You're getting a lot of love in the chat. Tom says, excellent presentation. Stephanie says, great webinar. Thank you. So thank you both. Really appreciate it. And we'll see you here next time. Cheers.
Great. Thank you, Joe.
Thank you. Cheers.
Bye, everyone.